good afternoon, everybody, depending on where you are in the world. Welcome to this month's CO Research Trust lecture. This is the latest lecture in our series, and what we're doing is we're trying something a little bit different. We've been joined by a number of researchers who I'll introduce over the next hour. Many of you will know Dr. Antony Nyombi, who undertook his PhD at Cranfield University, and his research was funded by us, the CO Research Trust, the Katie Haines Memorial Trust, and the Boat Safety Scheme. Antony, once completing his research, returned home to Uganda, where he's been working over the last few years. He and I have kept in touch, and he's kept up with the research that we are funding and supporting here in the UK, and we've discussed his interests there in Uganda. Most recently, we talked about the amount of research that's going on into indoor air quality across sub-Saharan Africa. And so he and I agreed that we would create an informal project called CO Research for Africa, which is primarily based in Uganda and is being coordinated by Antony. So today is, I guess, the launch of that. It's an opportunity for Antony and I to work together again. And the aim here really is to promote collaboration between those researchers working on CO and air quality in sub-Saharan Africa and UK-based researchers with a view to funding a collaborative research project or seeking funding from one of those institutions that supports international development funding, things like that, with a public health focus. Before Antony presents, I don't know, Antony, whether you want to, add to that a little bit and just give your perspective on, where we've got to and how we've got here.
Thank you very much, Mr. Adrian. As he's mentioned already, this originated from my CO project that I did at Cranfield University, which was funded by the CO Research Trust, the Katie Haines Memorial Trust, and the Boat Safety Scheme. I would like here to thank the funders, the three organizations that were involved. I would also like to thank my supervisors, especially Dr. Roland Wesling, who looked for the funds for the research and entrusted me with the research itself. So as Adrian has mentioned, after my PhD, I returned back to Uganda. I continued doing my research and as well as doing consultancy work. And we kept talking about research here and there. But at one point, was it around 2023, there was a paper which was released by the Global Burden of Disease. We were looking at global carbon monoxide mortality and morbidity, and we're using simulations to estimate the death and injuries caused by carbon monoxide. And in that paper, one of the big challenges they found was lack of data, especially in low-developed countries. And that really struck me so much. And we talked about it with Adrian. And I was like, I have to do something really to make sure that there is enough data, especially in Africa here, to make sure that policymakers, healthcare professionals can make informed decisions on policies and mitigation measures to make sure that they help the people in Africa. So several emails were exchanged here and there, and that's how we came up with the CO Research for Africa. And today I'm happy that it is being launched with this lecture as an introduction, and I hope it goes all well. Thank you very much.
Thanks, Antony. So Dr. Nyombi is our first presenter, so I'm going to hand back over to him. And Antony's presentation is called Enhancing Carbon Monoxide Detection and Data Collection in Sub-Saharan Africa. So Antony, the floor is yours. Thank you. Anthony, you're on mute, I'm afraid.
Okay, can you hear me right now?
Yes, we can. Thank you.
All right. Greetings, everyone, and welcome again to the launch of the CO Research for Africa. And we are happy that the CO Research Trust has accepted to work with us here in Africa to enhance data collection and accessibility to enable policy makers and healthcare professionals do informed decisions and governments to be able to fund and do mitigation measures as far as carbon monoxide morbidity and mortality is concerned. My presentation is divided into small portions, 3 small portions, but very short really. The first one being the CO history. I've already talked about that. I want to go back to that again. I want quickly to go into CO, its exposure and related illnesses. All right, so we already know that CO is colorless and odorless gas from a complete combustion, and it has an affinity for hemoglobin of more than 200 times, and causes serious illnesses, okay, and most of them are cardiovascular diseases. We already realized that in our bodies, there's already some inherent carbon monoxide released by our bodies, which is about 1 to 2%. And but of course, with exposure, that level can rise tremendously. And in smokers, it can be between 5 to 6%. The major focus of our research we want to look at is mainly the low-level exposure, because the toxic acute levels are rare occurrences, but most of the exposures are low-level exposures. So we're talking about less than 50 ppm. So you realize that most of the people around the world are still cooking with open fires and inefficient cook stoves. So most of the least developed countries, people still cook with open fires. So every time you light a cook stove, charcoal stove or a wood open stove, you know that you'll be exposed to low-level exposures. And when you come back to my country here in Uganda, it's alarming that more than 94% of the population are still cooking firewood and charcoal. And this exposes them to a lot of low-level exposures and a few acute levels that cause fatalities here and there. But our major interest is the low-level exposures that we need to handle quickly and very well. Okay, these cause serious illnesses that I've talked about earlier, like acute respiratory illnesses, lung function problems, blood pressures, low birth weight. If a child is born with less than 2.5 kilograms, most likely if a mom has not been exposed to CO from cooking, they've been smokers or other causes. Okay, they cause esophageal cancers, sick building syndromes, and many other diseases. It's not only distributed through hemoglobin, but also other heme proteins, including myoglobin, cytochrome P450, dopamine, and others. So it's quickly distributed to the body, and autopsies have shown high levels in the blood, in the spleen, lungs, kidney, and of course in the brain. It's metabolized when somebody is exposed. It really takes time to break down. Its half-life is quite lengthy. When somebody is exposed to CO, when they're taken out of the exposure area and taken to the normal brains, breathing normal air, it can take more than 5 hours for the half-life of CO to be reached. That is half the amount of CO they've been exposed to. And if they're exposed to pure oxygen, it can take up to 80 minutes. That's about more than an hour. And if they go into a hyperbaric oxygen chamber, many operations in hospitals, they may take less than 30 minutes. And you realize most of these facilities are not available in less developed countries, so they must devise other means. It's excreted quite in different ways. You realize that pregnant mothers are at a very big risk when it comes to CO exposure, that their levels in body can be more than 20% of a normal person. And to a baby, their levels can be really, really high, more than 4 times compared to a normal person. And when it comes to the breakdown, it takes when a woman is exposed to CO, the fetus is even at a higher risk of getting fatality. So it's released from different sources, including, we've talked about cooking and heating using firewood and charcoal, but of course, smoking shisha and pipes can also be released from your neighbor, even if it's not you producing, but your neighbor can release it to you and enter through your doors and windows. And it can also be obtained passively if you're not a tobacco smoker, or exhaust fumes, and so on and so forth. Okay, its symptoms mimic most of the other illnesses like viral infections or food poisoning, and hence there's been a lot of misdiagnosis in hospital settings. And of course, like I've mentioned, people have different levels of CO in their bodies depending on whether they're smokers or not. So for a smoker, they have 1 to 2% inherent CO in their bodies, but of course, a smoker has more than that. So that brings challenges, and hence making carboxyhemoglobin not a very good indicator for exposure to CO. It causes a lot of other illnesses, including central nervous system diseases, and so on and so forth. And it's been detected with abrasions on the brain with people who have been exposed to toxic levels, even if they recover, but they remain with wounds and abrasions on their brain. It causes several cardiovascular diseases and so on and so forth. I'm not going much into that. So quickly on the ambient CO exposures in African cities, you see that most of the cities in Africa have really high levels. There are some highlights that you can see from Kinshasa in the Congo. Their levels, just ambient levels, are above 10 ppm per day. So you can realize that the levels, even in ambient level, are quite high. When you come to my country, Uganda, here, it ranges between 3 to 5 ppm. That's just ambient. So even the levels in the streets have to be really checked seriously. So I dive into my current project. We are assembling and developing sensors for enhanced CO detection and quantitation in least developed countries, starting with Uganda, and then shall roll it out to the rest of Africa and other countries if needed. In general, many people, over 90% of the world population, live under polluted air, and about 6.7 premature deaths were caused by air pollution. And in nearly 1 in 4 people globally, nearly 1 in 4 deaths have been caused by non-communicable diseases caused by poor air pollution. So just in this presentation, in this lecture only, if you count 1, 2, 3, the fourth person might have some illness caused by poor air quality. And about 2.1 billion people worldwide are still talking. I've mentioned that, and in Uganda, more than 94%. So the unregulated burning of carbonaceous materials and plastics have contributed to this bad air quality. And of course, indoor air pollution has caused tremendous death, more than 3.2 million deaths in 2020, including over 237,000. And these are children below the age of 5. And in Africa in general, we have a lot of poorly maintained and very old vehicles. So these contribute to a lot of ambient air quality problems. And because of low levels of research, you realize the burden of disease caused by these poor quality air from poorly maintained vehicles is not well quantified. We have industrial emissions, bush burning, and forest fires. Recently, our brothers and sisters in California are suffering with a wildfire. Already 24 deaths have been recorded and more to come, who are still nursing injuries and wounds in hospitals. They need our prayers, so we have to pray for our brothers and sisters in California. I've talked about CO, and from the global burden of disease, in a recent study in 2023, they mentioned that nearly 30,000 people die annually from carbon monoxide. And from the CO research done by the Clean Air Africa, more than 6,000 deaths occurs from charcoal burning and wood burning and cooking with those dirty fuels. And non-communicable diseases have caused a lot of health challenges. And you realize in the developed countries, more than 1.7% of their annual health spending is spent on non-communicable diseases, which are caused mainly by poor air quality. And in my country, Uganda, over $8,000 are spent on cardiac care. And for those only who can manage, the majority suffer in their villages and their fate is not really known. And for those who can afford, they can go abroad and spending more than $50,000. The majority of Ugandans can't really afford that. So it's really a big challenge. Why are we doing this research? As we mentioned earlier, there's scarcity of information, especially from least developed countries, which are characterized by inadequate waste management practices, high fuel poverty, low social economies, and limited adoption of new technologies because they're not affordable anymore. So the relationship between the exposures and the health effects are not well understood. And this is the case with carbon monoxide, which was studied and analyzed by the Global Burden of Disease. So most of the data available on air quality in Africa is on particulate matter. And in one study, this was only significant in 8 out of the 47 countries that were sampled. So you can imagine, if the general air quality, including particulate matter, which is easy to quantify, can only be viable for 8 countries out of the 47, how about the CO, which is invisible? And hence, most of the central governments are suffering with getting data to do mitigation measures and preventive actions. So whether this leave the least developed countries to the mercy of only those who can do this research and mainly based in other countries. And they use only country-specific covariance and country data, doing predictions and modeling. Oftentimes, these are not even accurate to the dot because they are only predictions. And hence, developing policy and strategic directions in such countries becomes a big challenge. So with the lack of such reliable data, that means that the true burden of CO and other related diseases remains unquantified. Public health officials, policymakers will not make evidence-based policies because of lack of this information. And because of the lack of evidence-based information, securing funding for such initiatives for mitigation measures also becomes a very big challenge. And of course, training healthcare workers because of misdiagnosis, because CO has symptoms similar to other ailments like poisonings, there's a lot of misdiagnosis. So training health workers becomes also a big challenge. And this limits the exposures to the exposures limits Africa and other least developed countries from getting the accurate burden of disease in those countries. And hence, the developed countries might look at Africa as having a less burden than it is actually. And this brings a high burden to healthcare systems, reducing workforce productivity and affecting household and national economies at large. So my team are looking at addressing these data gap challenges by improving data collection and reporting, using system registries in hospital settings, like recording birth, death, and the proper causes of death. And of course, recording the certificates properly with the proper information, including the CO information, which is rarely captured in many of the African settings. And we are looking at increasing access to diagnostic and testing equipment. Initially, we want to look at donating a few detectors and diagnostic equipment, which are affordable to some healthcare professionals in healthcare institutions, especially in rural areas where many people are exposed to CO through cooking and burning data fuels. And of course, educating healthcare professionals on how to use these diagnostic equipment. And we want to leverage on technologies by creating mobile apps and utilizing electronic healthcare records, and of course, developing web-based platforms where all this data will be captured and recorded for easy access to policymakers and different stakeholders locally and internationally, so that they can make informed decisions. We are, of course, looking at making collaborations, one of which we are doing with CO Research Trust, and locally looking at different other institutions, research institutions, and education institutions, universities. And currently, my team is looking at working with the Ernest Cook Ultrasound Research and Educational Institute, where we want to house our training center for the technicians to assemble our researcher, our detectors, and of course, assembling most of our detectors that we'll be working on. And definitely, we shall continue doing research to identify risk factors and causes of CO poisonings in Uganda, Africa, and other developed countries. So initially, as I've mentioned, we want to donate up to 100 CO oximeters to especially rural healthcare facilities and establish a centralized data collection system where all the data collected from these healthcare facilities will be recorded for easy accessibility. And we shall continue to assemble different sensors of interest. And we also want to support student research through scholarships. So our methodology, we are already importing sensor parts from countries where they are sold cheap. We realize that assembling sensors from locally here makes them very cheap and easily available and affordable to the local researchers, healthcare professionals, and all institutions that will be needing them. And shall continue to train technicians on assembly and optimization of the sensors. And our initial involvements have started with prototypes to build technical expertise in our researchers and in our technicians. And subsequently, we shall develop advanced CO-specific sensors and other multi-sensor devices. Okay? And we're looking at a series of sensors like CO oximeters, street-type sensors that will have a series of parameters, of course, including carbon monoxide, indoor sensors, research-type sensors, and industrial-type sensors. So we are already developing one, and our prototype looks like this on the outside. It has two sensors inbuilt, a CO sensor and a smoke sensor, and that's how it looks in the preheating mode. And in the measurement mode, it displays smoke and CO on the display unit, and that's how it looks inside. It's made from cheaply and readily available materials, including a cardboard housing, a microcontroller, which is a cheap one, an Arduino Uno, a breadboard for connections, MQ sensors, and many other parts. And for a finished product, the other one was for just training purposes, but after training our technicians, we shall develop better sensors from better parts, like better microcontrollers. Instead of using breadboards, we shall be using printable circuit boards, which we can do here in Uganda, 3D printed casings, Wi-Fi modules, and for street-type sensors, we shall have solar panels to power them, and so many other parts. So for a street-type sensor, we're looking at something like this you're seeing on the screen. That's what we're envisioning. And we shall put this in several towns and cities of interest. And we're rolling out this project, starting with Uganda and then the rest of Africa. Those are some of our references, and thank you very much everyone for attending. Thank you very much to the CEO Research Trust and the organizers. Thank you.
Anthony, thank you so much for that presentation. There's lots in there. I think we you know, if we had more time, we could discuss in more detail. But I can really see how this builds on your PhD and the work that you did around designing, you know, catalysts to prevent CO being produced by charcoal, which, you know, is clearly a significant issue in terms of the way that cooking and heating takes place in parts of Africa. I was also interested in that different fuel mix. I think the issues you talked about around the data issues and the challenges there, I found myself sort of nodding along and thinking, you know, this is a global issue. We're having the same discussions, and I know that Isabel Myers is on the call, and perhaps after the presentations are finished, we can bring Izzy in, because I know that she's been doing so much work on data over many years. She's involved with a big project here in the UK, and she's also been leading the charge in terms of improving the data collected by coroners and looking at issues around the ICD coding which healthcare professionals use, and the technology as well. These are things that we as an organization are taking a much greater focus on. I think that it's really important to get the technology in the right places, and it's appropriate for both the environment, the circumstances that are being used in. There's an organization in Canada called the Prism Institute. We're based out of Toronto, and they have a very clever risk management tool which empowers local communities to identify and manage risks at different levels. And I think it'd be really useful to perhaps arrange a call in the coming weeks with their president, Shrikant Mangalam, who I think would be able to help with some of the things that you've talked about. But yeah, thank you so much. It's always great to see you and to work with you. I'm quite conscious of time, so I thank Anthony for his presentation. And the next presentation is by Professor John Kayode, who's Professor of Exploration Geophysics at the Nigerian Army University. His presentation is on air pollution by CO, poisonous gas in the Lagos area, southwestern Nigeria. So I'm going to hand the floor over to Professor Kayode. Thank you.
Good afternoon, everyone. Thank you for the opportunity to present the first lecture on the Carbon Monoxide Research Trust Africa Research Project. My name is Professor Dr. John Stephen Kayode, a professor of exploration geophysics from the Nigerian Army University, Biu. The topic of my talk is on air pollution by carbon monoxide poisonous gas in Lagos area, southwestern Nigeria. My email, my phone number, my research ID are also shown on the slide. My talk is divided into 6 subunits. The first unit is the overview of carbon monoxide research. The second one is the specific aims and objectives of why we need to carry a carbon monoxide gas poisonous research. Why the carbon monoxide research in the first place? Data collection is the fourth one, followed by the results we obtain from the field data collected and the conclusions of my talk. Carbon monoxide usually absorbed by our lung alongside with oxygen, and then the oxygen and carbon monoxide will enter into the bloodstream through our lung. Thereby, the normal oxygen is filtered into the bloodstreams. Meanwhile, the carbon monoxide presence in the lung will now prevent oxygen from entering into the bloodstreams. Many are suffering with heart-related diseases as a result of carbon monoxide poisoning gas, including children, pregnant women, infant babies, and individuals. According to the World Health Organization, air pollution is responsible for over 6.7 million premature deaths on a yearly basis. When carbon monoxide poisoning gas enter into the bloodstreams, as the body inhales the gas, it combines itself to hemoglobin to form carboxyhemoglobin, which is toxic and deprive our cells from taking oxygen. Just last month, December 2024, report by BBC and others said that 12 people lost their lives in Georgia at ski resort due to the carbon monoxide poisoning gas inhalation. Majority of these people are from the Indians. Research by NASA from the Earth observations recorded the global carbon monoxide poisoning gas in the environment. And surprisingly, West Africa, particularly those countries that are close to the coastline or the equatorial line, are so high. The highest are shown on the global map by the right-hand side on the slide. It's so alarming, and this is a source of concern. The reason for us to take up this research, the motivation of the study is to determine the level of human exposure to this deadly gas using a carbon monoxide detector so as to create the necessary adequate awareness of the quality of air within our metropolis, whereby preventive measures could be put in place. Though we have various potential sources of carbon monoxide poisoning gas, particularly in our homes, as shown on the slide. In the most populated urban city of Lagos, southwestern part of Nigeria, exposure to the carbon monoxide pollution caused by households wood burning for cooking, generating sets, and vehicular emissions of the CO gas was examined in this paper with a view of putting preventive measures to curb these devastating effects on our people. As you can see from this slide, carbon monoxide gas is not just emitted only in our homes. We have emissions from industrial setup, aviation by aircraft, heavy-duty vehicles and machines and equipment. Thereby, carbon monoxide emissions into the atmosphere influences the amount of greenhouse gases that is present in our atmosphere, which causes global warming and climate change through increases in the temperature of land and hydrogeological bodies that leads to alterations of ecosystem. Hence, carbon monoxide gas plays a major role in our atmospheric chemistry as shown by carbon cycle. As previously said, the deadly gas enter into our bloodstreams and form high affinity with hemoglobin. Most of the carbon monoxide gas absorbed will be found in the blood as carboxyhemoglobin. Therefore, it's present in all tissues of the body. Level of 50% carboxyhemoglobin may result into coma and eventual fertility. The symptoms carbon monoxide into the lung is still resemble poison infection such as tick, general body weaknesses, making it possible to easily detect or diagnose. Healing of all forms results in when it enters the lung, causes difficulty in breathing, confused by attacking brain, blood pumped by our eyes, loss of consciousness, headache, and so on. The CEO to record three principles was what lead to location of area. Three, just
Hi, Dr. Coyote. I'm afraid that the sound keeps breaking up here. I don't know whether it's possible that you could deliver the rest of the presentation live, because it's very hard to the sound is breaking up on the recording. I don't know whether you're able to share your slides and do the rest live. I'm sorry to put you on the spot.
I'm happy to continue sharing if Professor Coyote just tells me when to go to the next slide.
Okay, is that okay?
Thank you very much. It's quite unfortunate that the voice is cracking. Where we stop on this slide, I will continue. The data collection was taken by the census zone on the right-hand side of the slide. And the parameters we adopted in the data collection. One, accessibility to the area of interest. Then central location and the congestion in these areas. Because Lagos, being the economic capital of Nigeria, has a lot of central business districts. Most of the locations selected are highly industrialized areas. The presence of heavy factories and vehicular movement in the metropolis. Most especially publishing houses, television stations, commercial shops, and residential buildings. In all the areas selected, there is always heavy vehicular presence that continuously emitted the carbon monoxide gas. Most especially Apapa area, where we have the largest port in the country. We have the Festac areas where we have a lot of heavy presence of industries and factories. Then Ikeja areas. All these were selected because of the heavy presence of industrial sites in the area. On the other hand, Ikoyi residential area was also selected together with Bagada as the commercial area in the Lagos metropolis. The research targeted a minimum of sample size of 10 cars using petrol fuels, 9 trucks with diesel engines, 6 motorcycles, 5 petrol domestic generators, 5 diesel domestic generators, 3 household kitchens, 2 eatery kitchens, 3 commercial areas, 3 residential areas, and 2 firewood cooking areas per set of readings. From the graph on this slide, we could observe that diesel engines saw the highest data recorded, followed by the petrol engines, cars, trucks and motorcycles. The minimum values of about 45 ppm to a maximum value of 335 ppm were recorded during the data collection. Generally, the values recorded during the field work were influenced by periodical changes in the environmental settings of the area. So the graph shows the average value of CO emissions in Lagos, Nigeria, using different sources. Next slide. Also, values collected from other sources apart from vehicular and industrial areas shows minimum value of 1 ppm to a maximum value of about 96 ppm. It was observed from the graph shown on the right-hand side that the highest value of CO gas emissions were recorded in the commercial area relative to other sources. This could be due to high volume vehicular movement, human activities that are taking place, particularly in the market, such as grinding of all kinds, smoking, wood burning, wedding works, and so on and so forth. The graph at the right-hand side shows the commercial in comparison to residential, and then household kitchen and commercial eatery spots. Next slide. These activities that were taking place at the time the data was collected shows variation in values that is a function of how long this activity lasted. Particularly, high concentration in carbon monoxide emissions shows that increase in the activities at the point of data collection in the areas sampled. And low concentration in carbon monoxide emissions shows less activity at the point the data were collected. Next slide. From this graph, the average value of CO emissions from different sources and different environments in Lagos area was plotted as shown in the slide. From the corresponding graph, it was observed that trucks produce the highest value of carbon monoxide gas emissions in comparison to other sources. Also observed that generators operating on diesel engines, diesel fuels, recorded more CO emissions than generators operating on petrol fuels. It is therefore safe to conclude that diesel engines have higher emissions of CO gas than petrol engines as recorded in this research work. This could also account for the high concentration of CO recorded in trucks. But on the other hand, firewood, cooking spots, eateries, and household kitchen produce relatively lower values of CO gas emissions, which were permissible by the WHO permissible standards. Next slide. In conclusion, in as much as fossil fuel are being used to run automobiles, domestic generators, cooking, and other related activities, carbon monoxide gas will be emitted into the environment, thereby making it unsafe. From the results presented, the automobile dominates other sources of carbon monoxide gas emissions within Lagos and its environs. Therefore, the carbon monoxide gas emissions from the domestic generators might not be unconnected to the rate at which some families are being wiped out due to fumes from generators kept within the flats or at an enclosure in the residential buildings. Next slide. The chart from WHO on the right-hand side of the slide shows the value from 0 ppm to the maximum of permissible value between 5 and 700. But anything above 800 ppm are very dangerous and it could result to death. On our research, we were able to record above this 800 ppm in the industrial areas of Lagos. The level of CO emissions from commercial area, residential area, household kitchens, and eateries is tolerable by human system as obtained from the data collected in Lagos metropolis, and considerably less threatening in accordance with the World Health Organization permissible values. However, adequate measures must be taken to put in place to support innovative research as this for sustainable environment for all and sundry, particularly in Africa. Next slide. As previously said, the research was taken from my work with a student in 2013, as published by the Journal of Atmospheric and Climate Sciences. Other sources of information are so cited in these references slides. Next slide. Thank you for your kind attention and opportunity to be part of this first lecture on Carbon Monoxide Research Trust African project. Questions?
Thank you, Professor Coyote. That's a really, really interesting presentation. Thank you for delivering it live rather than the pre-recording. There's been some great conversations in the chat, and I think what we could do is we can deal with all the questions and have a discussion at the end. So thank you for that. Our next presenter.
Thank you, Adrian. Thank you very much.
Thank you. Thank you so much. Our next presenter is Mastiwal Endeshore Gebnet, who is a PhD candidate working with Professor Yu-Pin Yu on the International Health Program at the School of Medicine at the National Yang Ming Chiao Tung University. I hope I've got that pronounced vaguely right. Apologies if I haven't. This presentation is called The Association Between CO Exposure and Acute Respiratory Infection Amongst Children Under 5 years old in Ethiopia. In the name of time, I'm going to say no more and hand over now to Mastiwal, please. Thank you. We've got some great questions in the chat, and before we start, I'd like to bring one of the CO Research Trust's trustees into the conversation. Roland Wessling is a recent recruit to our board, although he's been known to us for many, many years, has been a big voice in this space. I'll let him introduce himself and how he's come to be involved here. And the other connection is that when Anthony did his PhD, Roland was one of his supervisors, or primary supervisor. So if you bear with me, I'm just going to see whether I can get the technology to work to bring Roland in. Thank you. Oh, there we go. Let's see if the technology works. There we go. Happy days. Hi, Roland.
Hello. I think that, blimey, that was not the background I meant to show, but never mind.
Yeah.
Hello.
Yeah. Well, thanks for joining us, Roland. Obviously, you know Anthony well. I don't know whether before perhaps you come into the conversation, you just want to give the attendees a little background on how you've come to be involved in the world of CO.
Absolutely. Very briefly, I'm actually a forensic archaeologist, although I'm a scientist, but nothing to do with carbon monoxide until 2011, when my then partner, Hazel Woodhams, and I went camping, and we both suffered a severe carbon monoxide poisoning. Hazel died that night, and I somehow survived with very severe injuries. I spent 4 weeks in intensive care. I had multiple treatments with hyperbaric oxygen in order to try to recover from the carbon monoxide poisoning. And after the event and after 6 months of physiotherapy and hydrotherapy for me to actually get back to work, I was then approached by a parliamentary group in the UK that just wanted to hear my story. And it was basically the all-party committee on carbon monoxide safety. And when I attended that meeting, I realized that there was very little scientific representation. There were politicians, there were industry representatives, but there weren't very many scientists. So there, I set myself a goal to try to help increase the connection between carbon monoxide research and policymakers, but also to encourage more carbon monoxide research, which led me to the proposal that Anthony then did this fantastic research on. And just, I know he's going to blush in a minute, but he was one of our star PhD students with more published articles than any other PhD student I've ever known. So well done, Anthony.
Great. Super. Thank you, Roland. So where are we? Just quickly at the questions in the chat. I have a question from Dr. Mari Herigstad, who is the leader of the Sierra Research Group at the Sheffield Hallam University in the UK. And she has she got two questions here? No, yeah, sorry. Yeah. She's got a question here for Masterval. I love the study you've planned, and we're really excited to see the outcome. It'd be interesting if you could also include cardiovascular diseases as well as respiratory to get a full picture of the vasoactive nature of CO. Is there a reason for not doing this? Also, what is the reliability of the multi-gas detector, particularly at lower levels of CO? We've used these in the past, but we've been unable to find them and found them unreliable under 10 parts per million. Do you expect to have higher levels than this?
Okay, thank you, Professor. So,
Yep.
can I answer the questions?
Please.
So, for now, we focus on acute respiratory infection because when I review some of the literature, the ARI is still premature days around 80% in Ethiopia. So we just focus on ARI, but I think now it makes sense for including other respiratory disease also. And for the material, I think my professor will answer, but I think they use this material before in Eswatini. Yeah, I think they use this material before. Yeah.
Great, thank you.
Okay.
Super. The only question I had from your presentation was, are you taking into consideration smokers and non-smokers as part of the work that you're doing?
Yeah, we will in our questionnaire we will include in this. Yeah, and about the instrument of the multiple gas monitor.
It's quite hard to hear you, I'm afraid. I don't know if you can turn up the volume of your microphone. Apologies.
Can you hear me?
Yeah, I think so.
Yeah. The multiple gas monitor, the detection limit, the lowest is 0.5 ppm. Yeah.
Yeah.
So I think it's reliable for very low level of the carbon monoxide. Yeah.
Okay.
And this is also a project because in Masterwood's dashes, we will also detect other pollutants, including the particulate matter, PM10, PM2.5, and PM1, PM 0.5, 5 and PM 0.3. And also we will detect the volatile organic compounds, and also the bioaerosol, including the bacterial aerosol and the fungal aerosol, fungus aerosol, the molds. And so that's all related to the respiratory infections. So we were including that.
Okay.
And I think the CO is the most concern in this part, because according to Master was literature review, there's not very many study focus on this issue, that the correlation between the CO exposure to the acute respiratory infection. Yeah, and I think that will be, and we also as expertise from our university, then they get us many suggestions, and actually in this morning that two of our committee, they get us some very helpful comments. Yeah. So
Super.
yeah. Thank you.
Great. Thank you. Izzy, I've brought you into the discussion. Thanks. You've got a question in the chat there. I don't know if you want to just come back on that, the issue of smoking, because I know it's something that's come up in a number of studies that you've been involved in. And then, yeah, the floor is yours to ask your question to Masterwell.
Thank you very much, Adrian. And how wonderful to hear 3 fantastic pieces of work on CO. It really is heartening to see that we're getting this global attention to this problem, that we can see so many comparable aspects to, in terms of, for example, the sources that have been described, and obviously the health outcomes. So I really believe that this global, if you like, tackling of this this pollutant has, it has legs. But sorry, I could go on for a long time, as you know, and now I can't quite remember what Adrian asked me to do with regards to smoking, but could I just quickly go through a few points that I had so I don't forget, if you don't mind? Thank you. I was really interested, Masterwal, with your study, and I was just wondering whether those households where you find that the household air pollution has contributed to the child's respiratory problems, whether your study allows you to provide some sort of intervention which could then enable you to follow up with that child at all. I was thinking of it mostly when I was thinking of it in terms of ethics, because essentially if you find a problem, you'd then be leaving that child in that situation without any sort of recompense. So just that question first of all came to mind.
Okay, can I answer now? Or
yes, please do.
Okay, thank you, Professor. So for us, we concern on child. One of the reasons is that children and the women are spend more time indoor. So as we know, at least even if they spend more time indoor, so we can get the child at home. So in our questionnaire, we include different questions. If they carry the child when they're cooking, or where is the child staying when they are cooking. So we also include further questions about to know the exposure of the child. That's from the material of the household, the kitchen, or the use from the fuels or kitchen type. So we have different questions for evaluate that one. And also we include also for the householders, still we are contacting so in Ethiopia, So I mentioned earlier there are 10 subsidies. So from these subsidies, we choose one, which is the second, the most populated in the country. So in that we have health extension workers in each kabale or waradas. So we'll communicate them if there is under 5 children in that community, then after we get that information, we will make it lottery method. So we will communicate them to get the under 5 children first. So we can recruit that one.
Right.
So
and then you'd provide you'd help them by providing awareness on actions that they could take to reduce that exposure.
Yes, of course,
yeah. No, that's super. And so I could talk about this study all day. Would you also do any follow-up to check that the parents would continue, or the mother would continue to be aware of carbon monoxide, and that their understanding had helped them? So you get a little bit of feedback on that, on what you're doing, and it's not necessarily something to answer, but it's just something that maybe to consider.
After we getting the result, we will prepare counseling. We also prepare some discussion for the mothers. So we will promote this one. Yeah,
that's great. That's so good to hear. And obviously, really capture that data, because in a lot of the work that we're doing over here, we find that capturing that follow-up data and making sure that people still continue to understand, even when they're not necessarily so involved in the project, how that can help and how that can spread community discussion as well. So no, thank you. That's lovely.
Yeah, that's why also we consider both seasons, the summer and we know we want to compare this, especially for CO. We want to see the results. Yeah.
That's great. I wish you all the best with your study, and we look forward to obviously the results. That's really super.
Thank you.
No, it's a pleasure, and I'm very, very aware that I could end up hogging this questions session. So I just really wanted to say to Anthony and Professor Coyote how it was really interesting that the sources that we see, again, we are collecting data over here, looking at sources from carbon monoxide, but then bringing in a lot more information about the levels of exposure from those sources, so that we can start matching or putting standards in place for those. And I think that Professor Coyote, what we really see is that this need for sort of the equivalent of workforce exposure levels and standards, so to protect workers. And we're lucky over here that we have that, but certainly the work you're doing and collecting all the data could help push for a change in that area. So that's really important. Anthony, I was just wondering whether there is scope to match, maybe use a RAD 57 device that you're very aware of, in conjunction with yours, so that there's this sort of global understanding of how your monitor compares with something where there is already quite a lot of data, and that will then really help sort of bolster the data that you produce and the information that globally that you're collecting. So that was just a thought on that one, to maximize the data that you collect. I'm sorry, I could talk about data and carbon monoxide and science projects ad infinitum, but I think those are the main points that I wish to raise. And obviously, just really contact me, Adrian, through Adrian, or if you've got my email, I think Anthony you have, please do get in touch and talk things through, because there's quite a lot of overlap in terms of how we could help reinforce the work that you're doing and the data that you're collecting. So thank you very much.
I think this is probably the beginning of this project or partnership. That I think at the heart of this, it is about collaboration and finding ways that, you know, the researchers that we support in the UK to partner up with people working in Africa. And I'm quite conscious of the time. I know that Mari has a question, but before I go to Mari, we have a question in the chat. Okay. This is a technical question, I think. Master Wal, in terms of your the protocol for your study, I want to ask how the head of household was unable to provide informed consent for your study. So what was the criteria for that, I think?
Yeah, for the criteria, we will consider if they are willing to give information about their child, and also if they allow us to measure the real-time pollutants in their household. So if they are willing to give consent for, so maybe if one household have multiple children, we will include all of the child. So we will ask informed consent for both child, not only for one. So our criteria is this one. The one they allow us to give their child this information, also physical examination, and to measure the CO level in their homes.
Great, thank you. Thank you so much. So we've got about 10 minutes left. The question, or certainly Roland and Mari both have their hands up. So if we go to Mari first, and then we can go to Roland. And what I'd like to do perhaps is, well, after Roland's made his comments, perhaps Anthony, you could come back in, because what we haven't mentioned is really you've hid your light under a bushel somewhat, and you've not talked about the research that you did working with Roland. And I think it'd be really, really good to remind people what that was and where you got to. And one of the things that perhaps we can explore as part of this project is, how do we pick that up and how do we get that going? What you said about charcoal and its use in Africa or in some African countries, you know, it seems to me that this would be a really, really sensible thing to do. But anyway, if we go to Mari first, please, and then I'll bring in Roland, and then perhaps we can finish with you summarising your project. Is that okay? Thank you.
I'll be quick, Edwin. Can you hear me?
We can, yes. Thank you, Mari.
Brilliant. Thank you so much. These were really fantastic presentations, so London. Thank you, Master Wal. In particular, the idea of looking at children is, well, it's very close to what we're doing already in terms of developments. It was great. I've just got a quick follow-up from something that Izzy said to you, Anthony, if you don't mind. I love the prototype, by the way. Looks awesome. For the street level sensors, I wondered if you had any thoughts of also using that NASA resource, the Moppet Earth data, just maybe for comparison and expansion on the street level data. We have a problem in the UK in that we don't really have street level data, so I think it's really cool that you're doing it. I think we've got about 7 sites here that has street level CO data, which is abysmal. And so we've been trying to sort of map that onto the NASA Moppet, and I think it's a reasonable correlation between street level and the tropospheric data they've got. So might it be a helpful tool, even if the granularity is not great, especially in places where you can't get those street level monitors in, because obviously there'll be a limit to that. I was just thinking, because that's what we're trying to do here. So that's my only thought.
Thank you. Anthony, did you want to come back on that before we hand over the floor to Roland?
Oh yes, yeah. Thank you very much, Mari, and Izzy, because your questions are kind of related. So what we're doing, we're assembling these sensors, but of course we are comparing with already existing sensors that are already in play that researchers are already using in different institutions. And of course, the idea of comparing with NASA research is also very good, to be able to compare the ambient levels of pollutants, especially CO in this aspect, to see if we marry each other and how we can marry the two data sets and make quick recommendations from those. So that's a very good advice, and I think we shall be able to follow that. So yeah, it's a very good advice, and I think it will help us a lot. Thank you.
I think you're on mute, Adrian.
Aha, sorry about that. All I was saying, Roland, floor is yours.
Excellent, thank you. So this question may be a little bit too big now for the remainder of the meeting, but in my experience, certainly in the UK, there can be sometimes a chicken and egg situation where either there weren't that many scientists interested in carbon monoxide research, or they weren't aware that there was actually any need for it. At the same time, there may not be strong legislation that forces people into actually doing research into it. So one question I would have to basically all the panelists is, what do you think is the biggest hurdle towards more or better carbon monoxide research? Is it just financial issues? Is it just the amount of funding, which of course every scientist in the world, wants more money to do research? But is it funding? Is it the number of researchers that are out there? Are there just not enough researchers interested in carbon monoxide potentially? Or do you think you have enough of them? Or is it that, you need governments to implement stronger legislation in order to force manufacturers to work with you on developing safer products that produce less carbon monoxide? So what do you think, if you had a wish list that you could put together, what would be the top 3 items on your wish list?
Okay.
Sorry, Anthony, do you like to go first?
Yes, okay. Yes, thank you very much, Roland. Happy to see you again. It's a long time. And yes, thank you very much for the research that you supported. Your question is really big, as you've mentioned. But if I take it from the Ugandan perspective, the issue is the burden of CO and related illnesses is not well quantified, and the government officials don't see it as really a big issue, and they are not really keen on funding it. But if there is a way we could get some real funding, it's not that there are no researchers who are interested. The researchers are there, and they are capable of doing the research, but the challenge is the research really is not funded at all. So if there is enough data sets that can show that, yes, there is a big burden here because of a lot of data fuels that are being used at household level, maybe governments will put it on their list of priorities to be funded, or to develop necessary policies to make sure that it's minimized at a certain level, or to implement some cleaner fuel technologies that are going on. So number 1 of my list would be a little bit of funding to show the government, to actually generate data that the governments will be able to look at. Then later, I know once governments are able to see this kind of data being published, showing the burden that is available in the country, that is incurrent in the countries, they'll be able to come on and be able to solve this issue, because it's not only affecting the low people, but even the high income people use the combination of fuels, because electricity is very expensive. So you will find many families, including the super rich or rich, you may say, use a combination of charcoal and maybe gas and electricity. So they're not really aware. The problem is awareness. So to create awareness, we could do a little bit of research, generate data, and show the governments that this, there is a big gap here, and if you can come in and support, then governments will come in and be able to help out. That's what I can say on that.
Super, thank you. I'm quite conscious that we've only got a little bit of time. So Professor Coyote and Master Well, if I could ask you just to give your number 1, just one each, thing that you think would help promote CO research. And then we can have perhaps some, if you allow me to run over for a minute, we'll allow Antony a moment to quickly talk about his research, and then we'll have to save it, I'm afraid, for next time. But Professor Coyote, if you'd like to go first.
Thank you very much. I really appreciate the opportunity given. Although I've talked about the research that was done somehow, I mean, sometimes 2011. So we need to update by getting updated equipment to really look at not only in Lagos this time around. We have to look at the entire country, Nigeria, and then looking at the entire country, Nigeria needs a lot of resources. That means we have to, despite the security issues we have in the country, we need to be moving from state to state to really know the level of the carbon monoxide emissions in our major cities, usually major cities. So I'm looking for collaboration to really expand the program, the research, then getting students involved on board. The student I used that 2011 was an undergraduate student. And then I'm looking forward to see how we can work together and then come up with a better data analysis, better reports, thereby getting a better publications out of the reports.
Super. Thank you so much.
Thank you very much.
Thank you. Master Wild, do you have a comment, and perhaps Professor Pinyu as well? Do you have any comments to make on that? What you think would be useful, the most important thing to promote more CO-related research in sub-Saharan Africa?
Yeah, thank you. So I think resource would be the most important thing to do different researches to highlight these problems. So for this, it's a real time. So it's better to show in a real time concentration pollutants. Like to do this, it needs material equipment. So for this, more I would go for the resources. Yeah.
Super. Thank you. And Professor Pinyu, do you have any comments before we allow Antony to talk about his work? I think you're muted.
Thank you. I think Master Ward, she do a very good job in now is a PhD candidate. Actually, is the second grade, second grade or third grade? Yeah, third grade PhD student in my lab. So yeah, the IRB is under review because in for Taiwan and Ethiopia, if we go to get the interview with the questionnaire, we had the info concern and also the certification from the IRB board. So we are waiting for the review of IRB, and after we got the certification, then we can conduct our research. And I think maybe we will conduct it after maybe 1 month or 2 months. I think maybe yeah, we were still waiting for the certificate of the IRB. Yeah.
Great. Thank you very much. Thank you. I think just like before Antony speaks, I'm very conscious to run over, and thank you everyone for your patience and staying on the call. I think we'd be very, very, very happy to plug you into our network of PhD candidates who are doing similar projects here in the UK, because I think, I think doing a PhD can be very lonely from what I've been told. And I think having other people who are in a similar position working on research is very useful to bounce ideas and feel more part of the community. So if you want to get in touch, we can certainly make some introductions so that certainly the team at Sheffield Hallam that Mari leads, there are some great people there, I'm sure, would love to talk to you about your research tell you about theirs. And I think that that would be a really useful thing, you know, to become part of our little community. Anthony, you've sat very patiently whilst I've rambled on here. We're over time. I'd like to try and wrap up by 25 to 3 because we here in the UK, there's a number of us about to dash off and collect our children from school. If you have your elevator pitch ready, if you've got a minute and 30 to tell everyone about your PhD and what we might do next, if things go in the right direction. Anthony, when your marks get set, go.
Thank you very much, Adrian. I would like to thank Roland, first of all, for that project that he generated, and the CO Research Trust that did a very big job in funding this research. As Roland mentioned earlier, this research came out of an accident, actually an incident that where his girlfriend lost his life due to CO intoxication in a tent while they were camping, and he sustained serious injuries, which he's still nursing up to today. So in a way to prevent other people from getting similar exposures and incidents, he looked for funding and got this project rolling. So my project was about developing products and procedures to minimize CO intoxication. In the UK and many other parts of the world, many people use solid fuels, charcoal and wood for cooking and heating. So my project was about how do I make the charcoal release minimal amounts of carbon monoxide? How do I make the wood release minimal amounts of carbon monoxide? And the way I did it was impregnation of different catalysts on charcoal and wood. And at the end of the project, we were able to achieve it partially. The project generated 5 peer-reviewed publications in 3.5 years. So thanks to my supervisors, Roland Veseling and Mike Williams. So I developed a catalyst-treated solid fuel, charcoal, which released minimal amounts of carbon monoxide compared to when it is used when untreated. In brief, that was a project, and thanks to the funders and my supervisors. Thank you very much, Roland, and thank you very much, Adrian, for keeping in touch.
Thank you, Anthony. Right. Well, I'm afraid we're going to have to wrap it up here. First of all, I'd like to really thank all of our speakers and contributors for taking part in this. It's been a really, really interesting event. It's been, I think, really interesting to do something slightly different and have a panel of presenters talking about all the different good work that's going on. Anthony and I will go away now and we'll talk about what the next steps will be. I'd like to get perhaps a group of researchers together from the UK and those of you who are interested, who are working on air quality and CO in Africa, and to look at how we might start to pull together a collaborative project which might be suitable for, you know, research council or international funding. If I can thank my team for organising this event, and thank you all for sticking with us for the last hour and a half. It's been really, really fascinating. I hope everyone has a good afternoon and a good evening. Thank you very much, and we'll see you all soon. Take care. Goodbye.
Thank you, Adrian. Bye. Thank you, Anthony. Bye. Thank you, Lore. Bye-bye, everybody.
Bye-bye.
Thank you.
Thank you. Bye.
Thank you, Prof. Bye.
Bye.
Bye.